Hello, this is Yazev. We are back in another video. In the last two video, we have discussed how to solve the linear equation, the system of linear equation with the help of Gauss Jordan method and with the Gauss Seidel method. In this video, we are learning how to solve the linear equation, the system of linear equation with the help of another method known as Gauss Jacobi method. It has a resemblance with the Gauss Seidel method, so it will be easier to understand us. And we will learn this code with the help of our nodes as well as with the Python code. So without any further ado, let's get into it. As you can see guys, we are on our computer screen here. We got our nodes open here, so we're going to start the Jacobi method. We have to do the in the start we have to do the same things as we have checked with the Seidel method. We are going to check the equations first of all, that are those equations okay with the Jacobi method in the same manner as we have did with the Seidel method. Okay, so let's get started. So as you can see, we got here the three equations. So first of all, to check this coefficient of x should be greater or equals to the sum of the coefficient of y and z. So 2 is greater and equals to the 2. So first equation is okay. Then we will check the second equation with the coefficient of y. So as you can see, 5 is greater and equals to the 5, 3 plus 2. So it is also okay. Then on the third equation, we will take the coefficient of z, which is equals to 4. It should be greater than the sum of the 1 and 2. So as you can see, 4 is greater than 3. So all three equations are okay. So we will now we will convert these equations into the augmented matrix. We will take two augmented matrix here. First augmented matrix with the values on the right hand side of the equations, and the second augmented matrix with the equation of the left hand side of the on the equation. Okay, so here we got the left hand side equation matrix and the second matrix on the equation on the right hand side with the values. Okay, so first of all, what we have to do, we have to change this three equation with the coefficient. We just need to take the coefficient x on the left hand side and transfer all the things on the right hand side. Then we will get this equation, and we have to do the same with the equation 2 with the coefficient of y, with the y variable, and we have to do the same with the equation 3 with the z variable. So as you can see, we will get this equation with the x, with the y, and with the z. In the first iteration of the Jacobi method, the first iteration would be 0. X, y, and z should be equals to 0. So on the initial side, we will put the y and z equals to 0. Here we are going to put the z and x equals to 0. And for the z, we are going to put the y and x equals to 0. So we will got our second iteration, which is equals to x equals to 2.5, y equals to the 3, and z equals to the 2. Then we got our third iteration. For the third iteration, what we have to do, we have to take the recent iteration values and put into this three equations, and then we will get the new iteration, which is the third one. So for the third one, we will take y equals to 3 and z is equals to 2, and we will take x is equals to 2.5. So we will get the value which is equal x equals to 0, z equals to 0, and y equals to 0.5. So that's how we solve with the nodes. We solve the Jacobi method. So let's get on to the Python code, and we will check how we can solve Jacobi method with the help of the Python code. So here I have the code pre-written here. Okay, let's just get started. So here we got a code. Let's get started. So we got our first augmented matrix, as you can see here, and the second augmented matrix here. Then we got another variable which is initial guess, which is equals to 0, 0, 0. As I told you before, the first iteration of the Jacobi method should be equals to 0, so it is an initial guess. Like it's the first iteration for the Jacobi method, we are just going to define it because it is a standard. Then we are going to check here solution for the two iteration here. Let's just make this equals to solution. That would be good. And make this equals to solution also. Okay. So we are going to make another variable which is equals to the Jacobi method. Actually it's a function. We are calling a function with the parameters a, like augmented matrix, and B with the second augmented matrix and initial guess, and with the iteration which is equals to 2, as we have mentioned here. Okay, so let's make this iteration equals to 1 first of all, and remove this. Okay, then we got our print command here which will print the iterations. Okay, so just take this solution here. Okay, it will allow us to show the answer. Okay, it will print the answer. So let's get to the method here, which is doing the actual work. We got our parameters here. So first variable in the method we got n, which is equals to the length of a, like the length of this a matrix. Then we got x, which is making a copy of x node. X node is a initial guess, so it's making the copy of this variable here in the command. Then we have a loop here with the iterator this, and then we are going to it will run till the iteration, like iteration we got here equals to 1, so it will run one time. If we will do this 2, so it will run twice. Then we got x new equals to the x copy. We are making another copy of iteration, this iteration here. Then we are going to take another loop with the iterator I, and in the range of n, like in the range of length of a. Then if this condition runs, if this loop runs, so we will got another variable here which is sigma. Sigma equals to the sum, and it is summing the 2 here. It is taking the aij with the index of ij and multiplying with the x with the index of j. Okay, then we are running another loop here for j with the iterator j in the range of n, and then we have another if condition here which means if j not equals to I, then this condition will be run. Okay, then we got x dot new I equals to b with the index I minus sigma divided by a index I and I. So it will calculate the R value for the answer, xyz answer, and it will store, this command is storing the answer into the x. Then we are returning the x, and this x will be print here as we got here. Okay, no, this x will go in this solution variable, then this solution variable will be printed. So let's run this code here. Hopefully it will run. Okay, we got our first iteration here, second iteration 2.5, x is equal to 2.5, y is equals to 3, and then we got 2, which is z. Okay, so we got the second iteration correct. So let's just make for the second iteration here. So just we need to change this here, and we will run this program here again. So as you can see, we got our third iteration which is 0, x equals to 0, y equals to 0.5, 0.5, z is equals to 0, 0. Okay, and I have recalculated several iteration for the same question. So let's check with the 3 also. Okay, let's run this. Okay, now you can see we got x equals to 2.15, y equals to 3, z equals to 1.825, 1.825. So it means our code is running perfectly. So that's how Jacobi method works. So guys, that's all in this video. We will see you in another video. We will learn another method in that video. So that's all for today. Hope you like the video. If you like the video, make sure you subscribe the channel. We will see you in another video. Have a good day. Bye bye.
It's caught in the crossfire.